Hello friends, good afternoon and welcome back once again on the YouTube channel of BYJU'S Exam Prep. I'm Gourav Gupta and I welcome all of you to 500 most expected CAT Quant Questions part number 7. And in this session we are going to basically cover up some of the questions which are related to number systems. So friends, today's topic is number systems. I hope I'm clearly visible and audible to all of you. Friends, welcome back once again. Good afternoon, everyone. Good afternoon, Kushagra. Good afternoon to all the students who are already present in this session. I hope I'm clearly visible and audible, right? Okay. So yes, I can see that there are some students who have already joined in. And friends, welcome back. In the next part number 7, for 500 most expected CAT Quant questions. Now, previously in this series of sessions for quant, in the previous 6 sessions, we have covered different topics ranging from arithmetic and algebra. And today in this session, all the questions will belong to the concepts of number system. Now, not all these concepts are very easy. Okay, so today we are going to look at the questions of number systems, okay, and probably you'll learn a lot of things out of this session. Now I'll be conducting this session obviously in the similar manner the way we have seen the last few sessions. At the beginning, I would recommend all of you to take out one pen and a sheet of paper so that you can do some amount of rough work. All right, and we'll be taking on these questions one by one, right? So these questions will be taken one by one, and for every question, I'll be giving you 30 to 45 seconds in order to understand that question, and you can start solving the questions. You can interpret whatever you can based upon reading the question in those 45 seconds, and then we'll give you an elaborated solution for every question that I'll be covering in this session. So friends, good afternoon. All right, so we'll be starting the session in a few seconds. Let other students join in. Arjun, good afternoon. Aim to IIM. So one of the students with the name of Aim to IIM. Welcome. चलिए तो start करते हैं without wasting any time. So the first question will appear on your screen. I want everyone to respond with the answers. Okay, so give your 100%, give more than 100% in this session, and try to find out the answer for every question. So question number 1 on your screen now. A very common question. This one is you will see in many examinations. So question says that all the pages of a book have been added and the sum was found to be 1270. But the teacher told me that one page has been mistakenly added 4 times. Okay, please be careful with the language of this question. So the teacher told me that one page number has been mistakenly added 4 times. Which number was added 4 times? So what was the number of the page which was added 4 times mistakenly? All the pages of the book have to be so these page numbers should be added, and I've calculated the sum as 1270, but I made an error. So the teacher told me that one of the page numbers has been mistakenly added 4 times. Okay, I am giving stress on this particular line, so please be careful. So what is the page number that was mistakenly added 4 times? Any answer for this one? Now for this question, you may use this formula n into n plus 1 divided by 2. This formula gives you the sum of first n natural numbers. Now since all the page numbers of a book have been added, so I can say that n into n plus 1 upon 2, this value should be somewhere near to this number. Why I'm saying that it should be near to this number? Because this is not the correct value of the sum of the pages, right? सो दिस इज नॉट द करेक्ट वैल्यू। तो जो मेरा करेक्ट वैल्यू है वो इससे क्या होना चाहिए, वो इससे थोड़ा सा कम होना चाहिए, बिकॉज वन ऑफ द पेजेस हैज बीन mistakenly added 4 times. Okay, so I'll do a little bit of approximations, a little bit of trial and error, and I'll substitute the values of n. मैं n की value substitute करूंगा, and I would try that this value comes out to be a number which is a little less than 1270. ठीक है, so थोड़ा सा ट्रायल एंड एरर करने पे, like if I'll put n as 50, so 50 into 51, if the number of pages is 50, so 50 into 51 upon 2, that is 25 into 51. अब 25 into 51 का वैल्यू कितना होता है, 25 into 50 is 1250 and then 25, so 1275. So sum of first 50 natural numbers is 1275. ठीक है, सम ऑफ फर्स्ट 50 नेचुरल नंबर्स इज 1275, बट मुझे क्या वैल्यू चाहिए था, मुझे 1270 से छोटा वैल्यू चाहिए था। ठीक है, सो आई चेक फॉर सम ऑफ फर्स्ट 49 नेचुरल नंबर्स। ठीक है, सो 1 से लेके 50 तक का सम, 1 से लेके 50 तक का सम ये है, तो 1 से लेके 49 तक का सम कितना होगा, आई रिमूव 50 फ्रॉम दिस, सो इट विल बी 1225. Okay, now 1225 is a number well below this number. ठीक है, so 1225 should have been the correct value, and the value that I have calculated is 1270, which is obviously a wrong value. ठीक है, अब ये मेरा एक्स्ट्रा आंसर क्यों आया है, what is this extra value, how much is extra, 70 minus 25, it is 45. 45 मेरा एक्स्ट्रा सम आया because one of the page numbers has been mistakenly added 4 times. एक्चुअली में कितनी बार ऐड होना चाहिए था, एक्चुअली में एक बार ऐड होना चाहिए था, and it is added 4 times, so it is added for an extra of 3 times. So if let's say x is the page number, if x is the page number of the page which was mistakenly added 4 times, so I can say that the value of 3x, तो जो error आया है, error will be of 3x, उस पेज को एक बार ऐड होना चाहिए था, but we have added it 4 times, so the error is of an extra 3x. Okay, so this error 3x should be equal to 45, so the value of x will be equal to 15. All right, so 15, option D should be the correct answer to this question. So Harshit and Kirti, two students have given the correct answer. Guys, it is very important to understand, to be careful about the language of the question. Okay, so the page number has been mistakenly added 4 times. It should have been added once. It is added 4 times, so there is an error of 3 times the page number, which is equal to 45. All right, so that is the answer of this question. Let's move forward and look at the next question. So question number 2 on your screen now. Again, this is a very common question that you will find in number systems. Find the 1000th digit of a number n if n is the number made up of the numbers written from 1 to 1000 in that order. So what we are doing is we are writing the natural numbers 1, 2, 3, 4, 5, 6 and so on, one after the other. And this will be a number, very big number. So we'll have to find out the 1000th digit of this number. 1000th digit of this number. All right. So very common question you must have seen while doing number systems. Very, very common question. Generally, one should not take more than 1 minute to get an answer of this question. And if you are into a good practice, then you can get the answer in less than 30 seconds. So you just have to be systematic while while calculating the answer for this question. Okay, so if we are writing all the numbers starting from 1 up till 1000, Okay, so first of all, I will write single digit numbers. Okay, so single digit numbers, they will range from 1 to 9. Okay, so I can say that there will be 9 single digit numbers. Every number will have 1 digit. So the number of digits that I have written will be 9. So 9 digits are already written when I have written all single digit numbers, right? Now let us start writing two-digit numbers. So smallest two-digit number starts from 10 and the largest two-digit number is 99. Okay, so how many numbers are these? These are 90 numbers, right? So 90 two-digit numbers. Every number will have 2 digits. So a total of 180 digits are written. Okay, now once I'm done writing all single digit and two-digit numbers, total number of digits that I have already used is 189. Okay, I want 1000th digit. So how many more digits do I have to write? 1000 minus 189. So that is 811 more digits will be written. Okay, now when I'll be writing the numbers after 99, so all the numbers now will be 3-digit numbers. Okay, so I'll now be writing 3-digit numbers, right? Now, if I write all 3-digit numbers starting from 100 up till 999, so total number of 3-digit numbers is 900. When multiplied by 3, that is 2700. So I will consume 2700 digits. But I don't need to write 2700 digits. I just need 811 digits. Okay. So how many 3-digit numbers I will be writing if I want to write 811 digits? Listen to each and every word that I'm speaking very carefully. I have to write 811 digits using 3-digit numbers starting from 100. Okay, so how many such 3-digit numbers will be written? Okay, so 811 when divided by 3, I can say that the quotient will be 270 and the remainder will be 1. Okay, so quotient is 270. So that means 270 complete 3-digit numbers will be written starting from 100. That means after 99. So after 99, if I write 270 3-digit numbers, so it will be the last complete number written will be 99 plus 270. All right, that will be 369. So the last 3-digit number that will be written was 369. After 369, I'll be writing 370. Okay, so basically number will be like 368, 369, and so on. Starting from 1, 2, 3, and so on. It will be 368, 369. So this will be the last complete 3-digit number that I have written. ओके, ठीक है। अब क्या करना है, एक सिंगल डिजिट तो और रिक्वायर्ड है, तो सिंगल डिजिट अब 370 की थी, आई विल नॉट बी एबल टू राइट 370 कंप्लीट नंबर। ओके, सो 369 लिखने के बाद व्हेन आई विल बी राइटिंग 370, as soon as I'll write 3000 digits are over. Okay, so the last digit will be 3, the 1000th digit will be 3. So the correct answer for this question will be option B. All right. Am I clear to all of you? So I have explained it in detail. Okay. If you liked my explanation, please do press the like button. Come on, you can do that. All right. So the correct answer for this question will be option B. That is 3. 3 will be the 1000th digit of this number. Okay. Let's move on to question number 3. All right, the next question on your screen. If a number, so this is a number where A and B are single digit numbers. So it is given that A and B are single digit numbers, are 1-digit numbers. So A and B can be 0, 1, 2, 3, 4 up till 9. So if this number is completely divisible by 88, then you'll have to find out, this is an important word, the least value of A plus B. You'll have to find out the least value of A plus Careful, be careful with this one. आसान क्वेश्चन है. It is again based on some of the common concepts of divisibility. Okay, तो ऐसे बहुत सारे क्वेश्चंस किए होंगे. It's just that you'll have to perform all these things right now in this live session. So what is the least value of a plus b? A plus b का least value calculate करना है. All right. Let us understand this one. For a number to be divisible by 88, it should be divisible by 8 and 11. Okay? For a number to be divisible by 88, it should be completely divisible by 8 and 11. Right? Now for this number, first of all, I'll apply the divisibility rule of 8. The rule of 8 says that the number formed by last 3 digits should be completely divisible by 8. Okay? So 7b0. 7b0 ये number 8 से कब divisible होगा? When b is equal to 2 or 6. ओके, सो 720 एंड 760 ये तो ओरली भी कर सकते हैं हम. ठीक है, 720 is completely divisible by 8 as well as 760. Okay, so the possible values of b can be either 2 or 6. Okay, now I will find out all the set of values of a and b. Okay, minimize करना है तो हम b को 2 ले सकते हैं. ठीक है, so not only this one but I'll tell you how to find out all the possible values of a and b. ठीक है, so case number 1, when b is equal to 2. Now when b is equal to 2, the number will be 1 4 a 3 7 2 0. Now, after putting the value of b, I will apply the rule of divisibility of 11. Now, rule of divisibility of 11 क्या होता है? Alternate places पे जो sum होता है, they should be equal or multiple of 11. Okay, so I have marked 1 plus a plus 7 plus 0, that is 8 plus a should be equal to 4 plus 3 plus 2, that is 9. So from here, the value of a comes out to be 1. So when b is equal to 2, a is equal to 1. When b is equal to 2, a is equal to 1. So the value of a plus b, this will be the minimum value because option may be a minimum option hai. So 2 plus 1, that is 3. So 3 will be the answer of this question, right? ओके, सो आंसर अगर करना है तो सीधा सीधा हम ऑप्शन ए मार्क कर सकते हैं. Now let us calculate the other values of a plus b. और कोई वैल्यू हो सकती है. So this can be possible when I'll look at the second case where the value of b is equal to 6. So the number will become 414 a 3760. Okay, now let's add these numbers. So here 8 plus a, I can say that this will be equal to 4 plus 3 is 7, 7 and 6, 13, 13, and the value of a will be equal to 5 from here. ठीक है, so a plus b का value क्या हो जाएगा? 6 plus 5, 6 plus 5, that is 11. Obviously ये आंसर ऑप्शन में ही नहीं है, ऑप्शन में हो सकता था ये आंसर, but we already have got our answer. कीर्ति a की वैल्यू नेगेटिव कभी नहीं होगी. ठीक है, so this is how you can do that. I hope you have understood this. Okay, so a can never be negative. So if you are equating them, that means the sum of the digits at alternate places can be equal or their difference can be equal to 11. Okay, so this is one thing that you can apply in this question. So the correct answer here will be option A, that is 3. All right, ठीक है, चलिए क्वेश्चन नंबर 4 पे चलते हैं जल्दी से. क्वेश्चन नंबर 4 बहुत आसान क्वेश्चन है. So if you have done number systems, if you have done divisibility rules, you will be able to quickly give the answer of this question. बहुत easily दे पाओगे. और बेसिक अगर डिवीजन भी आती है किसी को तो इस चीज का आंसर बहुत इजीली आ जाएगा. चलिए देखते हैं हाउ मेनी ऑफ यू आर क्लियर विद द बेसिक कांसेप्ट्स ऑफ डिवीजन. तो जो बचपन में डिवीजन करते थे ना, लेफ्ट हैंड साइड से स्टार्ट करके ऐसे नंबर्स को कैंसिल करके, वही चीज अप्लाई हो जाएगी यहाँ पे. So there is a number which contains 8, and these 8s are written 66 times. You have to find out the number, this number, which is formed by writing 8 66 times, is not divisible by which of these numbers. All right, Kirti. Okay, so you just need to look at some examples for this. So if I write 8 twice, 88, just like this. So I can say that 88 is divisible by 11. Yes, it is. After this, if I write 8 two more times, 8, 8 and 8, 8. So definitely this part is divisible by 11. This part is also divisible by 11. I can say that the complete number will be divisible by 11. Okay. So if I keep on writing 8s in the pairs of 2, okay, then I can say that the number formed will be divisible by 8. We are writing 66 times. So 8, 8, 8, 8, 8, 8. How many groups will be there? So there will be a total complete groups बन सकते हैं. Yes, 33 groups बन सकते हैं. There will be 33 groups of 8, 8. ठीक है? So I can say that since these 8s can be divided in the groups of 2, 2, 2, 2, 2 digits, hence the entire number will be divisible by 11, and hence 11 will not be the correct answer. Okay, because we have to find out it is not divisible by which of these numbers. Similarly, when 8 is written 66 times, can it be divided in the groups of 3 digits? So 66 3 से completely divisible होता है. Yes. So I can divide it in the groups of 3 digits. Okay, 3 3 के groups में 8 को मैं divide कर सकता हूँ. And likewise 66 8s completely divide हो जाएंगे. So the number given is also completely divisible by 111. Hence option B is not the answer. For the third option, double one, double one, 4 times 1. Now, can I divide 66 eights in the groups of 4, 4, 4, 4 digits? No, I'll not be able to, because 66 is not divisible by 4. Okay, since I cannot divide it, so I can say that the number is not divisible by double one, and hence double one will be the final answer for this question. Okay, so option C is the correct answer for this. सिंपल क्वेश्चन था, बेसिक डिविजिबिलिटी रूल भी समझ में आता है, बचपन में डिवीजन किया है अगर इस तरीके से, तो भी इस चीज का आंसर निकल जाएगा. ठीक है, चलिए नेक्स्ट क्वेश्चन पे चलते हैं. क्वेश्चन नंबर 5. Now question number 5 is a tricky question, very tricky question. Now if n factorial has exactly 15 prime factors, how many values of such n are there? n factorial has exactly 15 prime factors. 15 factors नहीं है, 15 prime factors हैं. Be careful, and the number given is n factorial. So you can start with a small example like 5 factorial consider कर सकते हो. तो मैं explain कर देता हूँ. 5 factorial basically होता क्या है? 5 into 4 into 3 into 2 into 1. How many prime factors are there for this number? So this is one of the prime factors, this is another prime factor, and this is another prime factor. Okay, so there are 3 prime factors of 5 factorial, right? Likewise, we'll have to find out the smallest value of n. First of all, सबसे पहले smallest value of n find out करनी है, such that it has exactly 15 prime factors. So first of all, find the smallest value of n. उसके बाद देखेंगे, but सबसे पहले n की smallest value calculate करो. I'll give you 30 seconds for this. Okay, now continuing the example that I have given, 5 factorial. This is a number having 3 prime factors. We have already seen. If I look at one below this, 4 factorial, it will be 4 into 3 into 2 into 1. This number will have only 2 prime factors. So I can say that 5 factorial is the smallest number having 3 prime factors. Okay, 3 prime factors, ये smallest number है. इसके बाद नंबर देखते हैं 6 factorial. So 6 factorial is 6, 5, 4, 3, 2, 1. So again prime factors कौन से हैं? यही 3 है. So this 6 factorial also has 3 prime factors. 7 factorial लिखने के साथ ही एक और new additional prime number आ जाएगा 7. 7, 6, 5, 4, 3, 2, 1. So 7 factorial will have 4 prime factors. So I can say that 5 factorial is the smallest value of n such that n factorial has exactly 3 prime factors. Another number will be 6 factorial. So 5 factorial and 6 factorial, there will be only 2 values of n for which n factorial has exactly 3 prime factors. Okay. Now the same thing we will have to do for 15 prime factors. Okay. So 15 prime factors के लिए मुझे क्या करना पड़ेगा? First 15 prime numbers लिखने पड़ेंगे. Okay. So first 15 prime numbers 2, 3, 5, 7. ठीक है. 2, 3, 5, 7. 11, 13, 17, 19, 8 हो गए. Then 23, 29, 31, 37. Okay. Then 41, 43, 47, 53. कितने हो गए ये टोटल? 1, 2, 3, 4, 16 हो गए. ज्यादा हो गए तो 53 को हटा देते हैं. So 47 is the 15th prime factor. Okay, 15th prime number. So I can say that 47 factorial. 47 factorial will be the smallest number, smallest value of n such that n factorial has 15 factors. So इस number के 15 factors होंगे. 48, is it a prime number? No, it is not a prime number. So 48 factorial will also have 15 prime factors. 49 is not a prime number. 50 is not a prime number. 51 is not a prime number. 52 is not a prime number. The next prime number is 53 factorial. 53 is the next prime number and it will have 16 prime factors. So all the numbers starting from 47 factorial up till 52 factorial. 1, 2, 3, 4, 5, 6. 6, there will be 6 values of n such that n factorial has exactly 15 prime factors. So the correct answer of this question should be option D. Alright, I hope you would have understood the explanation. Let's move on to the next question, question number 6. Question number 6 is a very basic question based on the properties of numbers. Properties of numbers, properties of, chalo, abhi main hint nahi deta. I'll give you a hint after another few seconds. ठीक है? Yes, Kushagra, why not we'll consider 47 also. 47 तो फर्स्ट नंबर है ना, सबसे छोटा नंबर है. 47 फैक्टोरियल में तो 15 प्राइम फैक्टर्स है ही. Okay, 48, 49, 50, 51 and 52 will be the additional numbers. So the answer will be 6. Okay. Of the first 1000 natural numbers, how many numbers have an even number of factors? How many numbers have an even number of factors? out of first 1000 natural numbers. So I was telling you that this is the basic property of perfect squares. Okay. Now concept used will be the number of factors. So I can say that if a number is a perfect square, it will always have an odd number of factors. Okay. So a non-perfect square will have even number of factors. ठीक है? So that means आपको क्या करना है? What you have to do is out of first 1000 natural numbers, you'll have to find out how many non-perfect squares are there. Okay, so how many non-perfect squares are there? ये count करना मुश्किल है, so we'll count the number of perfect squares. ठीक है? Now to count the number of perfect squares, again I'll do approximations. 30 का square कितना होता है? 900. So till 900 there are 30 perfect squares. 31 square is 961. 32 square is 1024. So I can say that up till 1000 there are 31 perfect squares. So 1000 minus 31, that is 969, will be the number of non-perfect squares. And hence this will be the answer for this question. So there will be 969 natural numbers out of first 1000 numbers, which will have even number of factors. So the correct answer for this question should be option A. Option A, yes, it is the correct answer. Okay. Next question, question number 7. Again, based on very basic concept of number systems. So how many natural numbers are the factors of 240 but not the factor of 420? So you'll have to find out the numbers which are the factors of 240, but they should not be the factor of 420. Basic question, a very basic question. So obviously you'll have to do the prime factorization of these numbers. So this is the 2 raised to the power 4 multiplied by 3 raised to the power 1 multiplied by 5 raised to the power 1. 420 can be written as 2 square into 3 raised to the power 1, 5 raised to the power 1, 7 raised to the power 1. Okay, this is the prime factorization of these numbers. Now, first of all, I have to find out all the numbers which are the factors of this. Okay, so number of factors का simple formula होता है powers को consider करना है, सब में 1 1 add कर दो and multiply कर दो. So number of factors of 240 will be 4 plus 1, that is 5 into 2 into 2. So there will be 20 numbers which will be the factors of 240. Clear? Now, out of these 20, there will be some numbers which will also be the factor of 420, as in this. Okay. So now I'll find out all the numbers which are the factors of 240, as well as the factors of 420. So इसके अंदर common power of 2 देखेंगे, common power of 3 and common power of 5. Common power of 2 is 2 square. Common power of 3 is 3 raised to the power 1 and common power of 5 is 5 raised to the power 1, and we'll check the factors of this number. So factors of this number will be 3 into 2 into 2, that is 12. So there will be 20 factors of 240, and out of these 20 factors there are 12 factors which are also the factors of 420. So the number of natural numbers which are the factors of 240 but not the factors of 420 will be 20 minus 12, that is 8. So 8 will be the correct answer for this question. Now, to understand whatever I'm explaining you need to have the basic knowledge of number systems. If you don't have any basic knowledge, then it will be difficult for you to understand all these things. So if you think that you are not able to understand some of the concepts that I'm teaching you, then go through the chapter of number systems, have a look at the basics, and then once again come back and look at the recording of this session. Okay, all right. Let's move on and look at the next question, question number 8. Question number 8 is a question based on base systems. So I'll directly give you the solution of this. How many natural numbers when converted to base 5 are 4-digit numbers? Base 5 में 4-digit number होना चाहिए. Okay, so we'll have to look at all the natural numbers in base 10, which when converted to base 5, the resulting numbers in base 5 should be 4-digit numbers. So what I'll do is, I'll look at the smallest 4-digit number in base 5. So smallest 4-digit number in base 5 will be 1000. Okay, and the largest 4-digit number in base 5. So largest 4-digit number in base 5 will be 4444. Because in base 5, the largest digit that can be used can be 4. Okay, so this is the smallest number, or this, and this is the largest number. Or what I can do is I can write the smallest 5-digit number in base 5. Okay, so from base 5, if I'll convert it to base 10, base 5 से base 10 में convert करेंगे, so this number will become 125. And this number will become 625. Okay, so a smaller number will be 624. So 125 in base 10 when converted to base 5 will be the smallest 4-digit number in base 5. Similarly, 624 in base 10 when converted to base 5 will be the largest 4-digit number. So numbers starting from 125 up till 624 will be all the natural numbers when converted to base 5 will be 4-digit numbers. So how many numbers are there? 624 minus 124. Okay, 624 minus 124, that is 500. So there will be 500 such numbers which when converted to base 5 will result in a 4-digit number. So the correct answer is 500, that is option B. Okay. Let's move on and look at the next question, question number 9. Question number 9, basic question based on the properties of HCF and LCM. Now this one is for HCF. If the sum of two numbers is given as 528 and their HCF is 33, then how many such unordered pairs exist? So ऐसे कितने unordered pairs exist कर सकते हैं? HCF is 33 and the sum is 528. Get familiar with this question, understand this question हमें करना क्या है. Again, based जो भी मैंने questions लिए हैं, yes, most of these questions are very important. They might look difficult if you don't understand the basics of number systems. Now, for those who understand the basic of number system, these questions will look like very simple questions to all of them. Now, highest common factor of these two numbers, let's say the numbers are n1 and n2. Highest common factor is 33. The factor of these numbers is 33. Okay, that means the numbers should be the multiples of 33. Okay, so I'll assume the numbers as 33x and 33y. Okay, so 33 into x and 33 into y, these are the numbers. Now since 33 is the highest common factor, highest common factor का मतलब क्या होता है? ऐसा सबसे बड़ा नंबर जो मैं कॉमन ले सकता हूँ. That means after taking 33 common from both the numbers, the remaining part should not have anything common. That means x और y में कुछ भी common नहीं होना चाहिए, right? So what do we call such numbers as? These numbers are called co-prime numbers. Okay, so if 33 is the HCF of the two numbers, the numbers can be assumed as 33x and 33y, where x and y are co-prime with respect to each other. Okay. Now the sum of these two numbers is given as 528. So that means 33x plus 33y is equal to 528. So from here, I can find out the value of x plus y, which is 528 divided by 33, and it will come out to be 16. So x plus y is equal to 16, such that x and y are co-prime with respect to each other. Now 16 is a very small number. You can do hit and trial. So 1 and 15. So 1 and 15 are co-prime with respect to each other. Yes, I'll consider this pair. I'll write all of them. 2, 3, 4, 5, 6, 7, and 8. So this will be 14, 13, 12, 11, 10, 9, and 8. Okay. Now 1 and 15, yes, they are co-prime with respect to each other. 2 and 14, they are not. 3 and 13, yes. 5 and 11, yes. 7 and 9, yes. So there are 4 pairs of numbers which I can select such that their sum is 16 and they are co-prime with respect to each other. So the number of number of unordered pairs in this case will be equal to 4, and option B will be the correct answer for this question. Okay, let's move on towards the last question of this session. Again, a very basic question based on the concept of LCM HCF. Now 24 coconut trees, 51 palm apple trees. ये क्या होता है? Palm apple trees क्या होता है? I think there is some misprinting. चलो मान लेते हैं. And 57 erica trees have been planted in rows such that each row contains the same number of trees of one variety only. So there are two conditions. Each row contains same number of trees, and each row should have same variety of trees. Okay, we have to minimize the number of rows in which the trees may be planted. Very basic, straightforward concept. So what the logic will tell you, if you have to minimize the number of rows, you'll have to maximize the number of trees in every row. Okay, now since every row will have only one variety of tree, so 24 should be divided with a number, 51 should be divided with that same number, 57 also should be divided with the same number. So we'll have to find out the highest common factor of these three numbers. So highest common factor of these three numbers is 3. So 3 is the HCF of 24, 51 and 57. So there will be 3 trees in every row. Okay? Now for coconut trees, there are 24 coconut trees. Each row will have 3 trees. So the number of rows will be 3 into 8 is 24. Okay? So number of rows for coconut trees will be 8. Similarly for palm trees, there are 51 palm trees. So 3 into 17 is 51. So 17 rows will be of palm apple trees, and erica trees 57 hai. So 3 into 19 is 57. So 19 rows for erica trees. So total number of rows will be 8, 17 and 19. इनको add कर लो. 25 and 19, 44. So 44 will be the total number of rows in which these trees will be planted. So the correct answer for this question should be option C. All right. Again, ये भी simple question था, but logic पता होना चाहिए. ठीक है? So friends, that is all about these questions of number system from my side. I hope you would have learned something at least out of this session. Okay, if you like the session, please do press the like button. Invite your friends to view this session. You can share the link of this session with your friends, and you can subscribe to our YouTube channel of BYJU'S Exam Prep. All right. Now, friends, you can unlock your free trial on our application, right? So, access CAT with BYJU'S Exam Prep, the most comprehensive exam preparation platform. So, we are providing a 3-day free trial to all of you. So, you can log into our application. Okay, the link for the same is given in the description. Log into our application and you can start your free trial. All right. Now, new batches are available. You can enroll now for CAT 2023 comprehensive program. The complete details of the program are given on the screen, and you can also fetch all these things using the link that is given in the description of this session. You can get up to 90% scholarship by attempting a scholarship test, which is being conducted on 11th of June at 11 a.m. So you can register for this test by logging on to our application and can avail the scholarship up to 90% on CAT preparation programs. CAT 2023 month-wise study plan. Saral sir will be helping you in planning your studies for CAT 2023 on 6th of June at 7 p.m. So please do be a part of this live interactive workshop. 500 most CAT expected questions. This series will continue, which started on April 6th. So series 6th of April ko start ho gaya tha. We are in the month of June and we are still continuing this series for all of you. So those who have missed the previous sessions, they may go back to the recordings which are available on the YouTube. All right. So friends, that is all from my side. I hope you enjoyed this session. Thank you for being a part of this session. Have a wonderful time. Bye-bye.